So thank you, David. And I'd just like to say that I'm sitting on the land of the Wurundjeri people of the Kulin Nation, and I'd like to acknowledge their elders past, present and emerging. So I'm going to talk about ACEMS, the Australian Research Council Centre of Excellence for Mathematical and Statistical Frontiers. You see the date there, June the 25th, 2021, today's date. In some sense, it would have been great if we could talk about this a few years ago, because ACEMS is currently in its last year, so we are sort of coming to an end of our formal existence. But one of the things ACEMS is supposed to leave is a legacy, and I think we have. So I'm hoping that a lot of the elements of what ACEMS has been doing over the last 7 years is going to feed into what's going to happen with the Australian Data Science Network going forward. So just a little bit of overview. So ACEMS is a 2014 research centre. It started in July 2014. It will actually finish in December of this year. So there will be some elements of writing final reports and stuff going into next year, but for most people, it will finish in December this year. The webpage is there, and I encourage anyone to go and have a look at it. I'm really proud of our webpage. It's a lot of stuff. We've got 54 episodes of our podcast, A Random Sample. We've got lots of stories about outreach. We've got our outreach to schools, the Mathscraft, doing maths like a research mathematician program, stakeholder engagement, many things there. So the webpage is one of the good things about having been around for a long time is we've actually had the chance to develop that, and there's a lot of stuff on that webpage. So if anyone's interested, I encourage you to go and have a look at that webpage, and hopefully you'll find something there to interest you. So what are we doing now? Well, we're thinking about sustainability of our activities, obviously. And one thing that I've got in my mind is, like most other centres that are on short-term funding, all the staff, apart from the chief investigators, which are continuing staff at universities, most of the other staff are on fixed-term contracts, and they necessarily, those contracts have to finish when the funding finishes. But I'm very keen to make sure that the staff, both professional and academic, move on to their next positions in a way that we've helped them develop their careers. And maybe all the organisations that form part of the Australian Data Science Network might be interested in some of the people we've got available. So just a comment. All right, so ACEMS is actually an Australian Research Council Centre of Excellence. I've heard the Australian Research Council say they think centres of excellence are their funding scheme that actually provides the best value for money. They fund centres to quite a large amount. We've got upwards of $30 million over 7 years. And roughly speaking, what they expect a Centre of Excellence to do is capacity building, which is more than just research. And that's sort of what we've been trying to deliver on. ACEMS is a centre that's, I don't know why they call them centres, because they're all distributed. And in this case, there's 7 nodes. University of Melbourne's a host node, but QUT is like a joint host node. In fact, ACEMS was made up of 2 separate expressions of interest. One was led out of Melbourne and one led out of the QUT. So in a sense, QUT is sort of like a second central node. We've also got nodes at UNSW, Monash, Adelaide, University of Queensland and UTS. It's quite a big organisation now. These numbers aren't certain because they change all the time. I mean, this is roughly what we've got on our webpage at the moment. I know for a fact that we do currently have 20 chief investigators, which are the people who actually hold the grant with the Australian Research Council. We've employed postdoctoral fellows at our various nodes, and there's 20 plus directly employed in various capacities, and that's, you know, that changes when people move or join. We've got 14 professional staff. We've got more than 180 students at various levels, and I counted about 160 PhD students, and then we've got master's, honours and vacation students as well. We have a concept of associate investigator, which is someone who's not a chief investigator, but works on a significant project, collaborating with ACEMS, or jointly supervises a student, or has some other collaboration with ACEMS in an academic sense. We have partner organisations, and the representatives of partner organisations are partner investigators, and I'll talk a bit about that in the next slide. And we have affiliate members too. I mean, an associate investigator is essentially someone who works on research, who has a PhD. Affiliate members are people who contribute to ACEMS in some other way. It might be to do with outreach or our schools' education programs or things like that. There's the current partners. You might notice the colors on our logo down in the bottom right-hand side, and it's always been intriguing to me that all of our partners have logos in roughly the same colors. Vic Road's probably a little bit more green, but seems like muted black, blues, and greens are what you need to be involved in this area. But anyway, you've got some government organizations there, the Sachs Institute, the Institute of Marine Science, AT&T in America is also a partner organization, and each one of those partner organizations has representatives that interact with ACEMS researchers. We also have an idea of industry affiliates, which are those partners were on the original grant, and they committed to working with ACEMS. We've had a sort of more a program called industry affiliate that encompasses people, organizations that have a shorter term interaction. I mean, probably, but for timing, some of these organizations might have been partner organizations, but they've essentially started collaborating with ACEMS since we started. And you can see things like Surf Lifesavers and Red Cross. It's now the Red Cross Lifeblood Service, and DSTG and Bitcoin Group and various other things. So I'm at the moment working a little bit with the Bureau of Meteorology. So you see the similar sorts of organizations that to our partners in a lot of cases. So what about the actual research? Well, ACEMS is a broad church in the mathematical sciences, but it's not the complete mathematical sciences. So the way I describe it, and the way we've decided we describe it, is that we deal with a range of disciplines that are related by the fact they deal with randomness in some form. So you might say on one end, you might have very applied machine learning, applied statistics, but then we have theoretical statisticians. And in fact, our inaugural director, Peter Hall, was one of the 2 or 3 best theoretical statisticians in the whole world. Stochastic modeling, which is my expertise, simulation, complex systems theory, numerical mathematics, right through to mathematical physics. And the mathematical physics we do can be quite theoretical, involving universality classes and things like this. So, but there is a thread that the sort of ways, the sort of techniques that are used in all these areas sort of are related, and they all deal with randomness. The research is organized into 4 research themes: challenging data, recognizing the fact that the sort of data we have to analyze these days is not just things it's not just numbers you can put in a table. It could be, photographic, it could be images, it could be movies, it could be streaming, it could be, something taken out of the linear accelerators, or the accelerator in CERN in Geneva, where, you've got massive experimental data that produces, massive amounts of data. It could be data that's not all assembled in one go, that comes in time, and we need to make decisions based upon this data in real time. So challenging data is about data which is not like what you normally expect, or what might have been traditionally thought of as data in statistics, say 20 or 30 years ago. Of course, I would argue, and most of us would argue, that if you're going to analyze data, you've got to have some idea where it came from. You've got to have a model for it. And this doesn't necessarily mean a physical model. It could be a statistical model, but it's got to be some idea of the process that generated the data and some assumptions about it. And usually with the sort of data we're talking about, it's not feasible to just write down some equations and do a bit of mathematical analysis. It needs to be analyzed algorithmically, and the efficiency of those algorithms is really important. So we have a theme of enabling algorithms. And really the whole point of it is to make informed decisions about what the data means, or what actions we should take to optimize something based upon the data. So we think of this as, data modeling, algorithmic development, decision-making as sort of like a process which is sort of logical. And of course there are feedback loops. A model might if you've got a model, you might go back and say, well, what can we get some data which is going to support that model? And there's obviously an interaction between algorithmic development and modeling. So, but roughly speaking, there's a process there. And we do have these things called collaborative domains, very wide, broad things, you know, and we started this out 7 years ago in 2014, healthy people, sustainable environments, prosperous societies. I think, you know, the subsequent experience we've had indicates that they're all really important things, and they're related, of course. You know, we've got the massive challenge of the pandemic, and clearly healthy people's that fits within that collaborative domain. Environments, I mean, there's a relationship between environment and people's health, and also you know, the health of the whole ecosystem, and prosperous societies.